all squared with respect to dx. Does that make sense? So this is just a formula. You don't need to know it. I'm just showing you. The limits would be between pi over 2 and 0. So you're basically just solving that. That's it. And fortunately, you should be able to do that if you're able to do part B, because it's pretty much the same integral. So you just take your answer to part B, you plug it in, and you get an answer. Do you have any questions on that? Okay. All right, so let's go from the very start. So, okay. Yeah, you ready? Okay. Question 8A, what did you get? Yeah, great, good job. And then part B? Careful. Yeah, that is one part, that's correct, but it's minus pi. So 5 pi cubed all over 24 minus pi. Okay? So you're missing that minus pi bit. So be really careful. 5i, what did you get? Not quite. No. So what do you set equal to you here? Yeah. So you would have dv over dx is equal to e to the x. So du over dx will be equal to 2x. V will be equal to the integral of e to the x. So that will be e to the x, right? So then when you use the formula, you should get u times v, which is x squared e to the x minus the integral of du over dx. So du over dx times v. So that would be 2x e to the x. Does that make sense? Now you run into another problem. You need to find out what this integral is. And to do that, you need to use by parts again. Okay? Does that make sense? So when you use by parts again here, so it's the integral of 2x e to the x with respect to dx. So what would you set u to be here? Yeah. So then du over dx would just be 2. V would just be e to the x again. So that means here you would have u times v, so 2x times e to the x minus 2e to the x. Very fortunately, that's just 2x e to the x minus 2e to the x, like that. So therefore, what can we do? We can just take this result and plug it in here. So your answer would just be x squared e to the x minus 2x e to the x minus 2e to the x. X squared e to the x minus 2x. Do you have any questions on that? Oh, and plus here, of course. That's right. Do you understand where you went wrong? Okay. And then for part 2, did you manage to show the result? All right. I know it's by substitution, but still. Okay. Use substitution, u is equal to Okay, so first of all, what you want to do is take the formula that they give you. So they tell you that u is equal to square root of 1 minus 3x. And then what you want to do is you want to find what du over dx is. So du over dx, oh, look at the substitution. It's just 1 minus 3x to the power of a half. So then it will just be a half times 1 minus 3x to the power of minus half multiplied by the integral, not integral, derivative of what's inside here, chain rule, multiplied by minus 3. So it should be minus 3 over 2, 1 minus 3x to the power of minus a half. Does that make sense? Now, are you sure about that, yeah? Okay. Now, we know du over dx is equal to all of this. So du over dx is equal to minus 3 over 2, 1 minus 3x to the power of minus a half. So now what we want to do is we want to replace this limit of dx. So we want to make dx a subject in a way. So to make dx a subject, I'm going to bring it over to this side. So you have du is equal to minus 3 over 2, 1 minus 3x to the power of minus a half dx. Okay? And then we're just going to bring everything over. So you have minus 2/3. Okay, what I'm going to do is I'm actually going to rewrite this because it might be a bit confusing. So I could rewrite this as minus 3 on the top all over 2 times square root of minus 3x like that. Do you understand that, yeah? So that means you would have dx is equal to 2 times 1 minus 3x, square root of 1 minus 3x, sorry, all divided by 3. And you can put a minus sign, dx like that. Does that make sense? Right, that's du. And then what you can actually do here is, remember, we want to express everything in terms of u. So if you look at this expression, remember, we don't want this in terms of x, we want this in terms of u. So can you see this is equal to u, actually? Do you see that? So therefore, I can just say dx is equal to minus 2/3 of u with respect to du. Does that make sense? That will be a key result. I can plug that in now. So if you look at the integral, what can we write this as? Well, we can write this as 27. What we can do now is we can write down, well, we can write down the bottom bit of the fraction, the denominator, as u, right? So we can say it's 27 all over u times x. But I don't really want to write x. I want to write this as u. So what we can do is we can try and make x a subject. So you got u squared is equal to 1 minus 3x. So x will just be 1 minus u squared all divided by 3. Does that make sense? So you got 27, and instead of x, you have 1 minus u squared all divided by 3. Okay? So when you change out the 27x all over square root of 1 minus 3x, you can just write it like this, right? So far. That's not the complete result. And then what do we need to do? We need to replace the limit. So the limit will just be minus 2/3 of u with respect to du. So you can kind of see everything's going to simplify kind of nicely now. This u can cancel out with this. So you're left with minus 2/3 times 27. If you think about what is a third of 27, it's 9. And then times that by minus 2, you got minus 18. So you got minus 18 into 1 minus u squared all over 3. Oh, look, you can simplify that nicely as well. Because then now you've got minus 6 plus minus 6 plus 6u squared, basically. Right? Minus 6 plus 6u squared. Do you see that? Are you sure? Do you understand everything I've done? This line here. Dx is equal to minus 2/3 u times du. Yeah, minus 6u. You integrate that, that will be 2u cubed plus c. Plus k, whatever you want to call it in this case. I'll call it plus c, of course. And then you can put your value of u back in. So that will just be minus 6 multiplied by 1 minus 3x plus 2 into square root of 1 minus 3x all cubed plus c. Okay? And we want to show that it's equivalent to this. So notice what they've done is they've taken out a factor of minus 2 and 1 minus 3x to the power of a half. So let's do that. So what we want to do here is we want to factorize 2. So take factor of 2 and 1 minus 3x to the power of a half. Yeah, so before we do that, let me just make this clear. So you got 6 times 1 minus 3x to the power of a half plus 2 into 1 minus 3x to the power of 3 over 2. So you take out a factor of 2 and 1 minus 3x to the power of a half. Notice this will be minus 3. So minus 3 times this will give you minus 6, whatever that is, right? And then you got minus, not minus, sorry, plus. So the 2 doesn't change, but you've got 1 minus 3x there. Does that make sense? So if you look at the powers, right, they've taken out a factor of 1 minus 3x. So then, you just need to multiply this by 1 minus 3x to give you this. So with that, now you can just simplify that. It's 3x power of a half. And all of this, make sure you put the plus c. What would that be? That would just be minus 3x plus 2, or minus 2, sorry. Yeah. Oh, 1 second, sorry. They took out a factor of minus 2, right? So actually, it should be 3x plus 2. Does that make sense? Yeah, so A is 3, B is 2. You did attempt the question, didn't you? Okay. I'll take your word for it. Alright, do you have any questions on this? No? Okay. Alright, this one. Question 5. Did you manage to do this? So, I mean, this one's a bit of trapezium, right? And the good thing about these exam questions, you can see that they don't typically tend to ask parts on its own. They like to mix it with other things. So, alright. So for A, what did you get for their two values? Okay. Did you say minus 7 pi over 4 root 2? It should be positive. You want to just double check that? Okay. What did you get for part B? Okay. Not quite. It's 11.91. And I only think the only reason why you got that wrong is because you used the negative value instead of positive. But yeah. So yeah, don't worry about that. That's okay. Did you do part C? What did you get? Yeah, good. And then part D? Yeah, good. Did you manage to do this question? Question 5 again. Okay. Just give me a moment. What did you get? Yeah, well done. All right, and then question 2 here. Did you do this? Mm-hmm. 1 plus 2 over e. Not quite. It's 1 minus 2 over e. So I'll just show you the mark scheme for this so you can see where you went wrong. Probably very small. Have a look carefully. You understand where you went wrong? Yeah. Okay, great. This question. Did you do it? Okay, great. Okay. Yeah, what did you get? Yeah. And then part 2A. Oh, you did show it, yeah? Great. And then part B. Yeah, well done. You got it. Great. Okay, that's really good. And that was it. Do you have any questions on anything that we did then? Now, there is, well, it's funny because in all the questions all the questions that we did today, you have yet to see the hardest question on integration by parts. I'm going to pose it as a challenge for you to complete. So, I do believe this question that I found on by parts is by far the hardest question you ever get on by parts. Okay, ever. And you'll see why when you do it. And when you look at it at first, you think, oh, it's not that menacing. But then you realize it will quickly transcend to hell. I'll just put it to you that way. Um, so let me just get this up, and then we'll probably just spend the remaining lesson focusing on that question. I'll give you 5 minutes, 6 minutes to do it, and we'll go over afterwards. It's a very interesting question, very interesting. I promise you that. Very interesting approach to it. Uh, 2 seconds. Just give me 2 or 3 minutes to find it. It may take a while. Okay, in the meantime, while I do find the question, just have a go at this. It might take me a while to find it, just so you are doing something. Ah, yeah, I found it. Okay. Did you manage to do this question? Hello? Okay. Okay, great. And you got the expression? Okay, great. Now, it's the second part of the question. The second and these two parts, they're not related. One's asking you to do something by institution. One's telling you to do it by parts. This is by parts. This is by thing. There's not really a common link between them, um, which is contradictory because usually it should be. But I guess the link is that they're both integration questions, nothing else. I'll give you 3 minutes. Okay, if you probably won't be able to finish the question in 3 minutes, but just see how much you can do. It's a difficult question. I'm going to show you what to do afterwards. Um, Are you getting somewhere? Have you gone anywhere? No. You run into an issue, and everyone runs into an issue. So let me go through the question, and I'll show you what that issue is. So they want us to integrate 3e to the x cosine of 2x with respect to dx. So the intuitive thing to do is set u equal to 3e to the x. And set, yeah, no, okay, that's good, I know. And set dv over dx to cosine 2x. Most people would. And so let's see what happens. So du over dx would just be 3e to the x. Well, it would just be the integral of cosine of 2x. Yeah? So that would just be half of sine 2x. Okay. So you would have u times v. So you would have 3 over 2 e to the x sine 2x. All subtract by du of dx times v. So that will be 3 over 2 e to the x sine 2x with respect to dx. Okay, does that make sense? Now, you're probably thinking, let's do by parts again. So we'll say u is equal to 3 over 2 e to the x. dv over dx is equal to sine 2x, right? So then you would have du over dx is 3 over 2 e to the x. You would have v is equal to minus half of cosine of 2x. Okay? Now, if we were to consider what would that be, so the integral of 3 over 2 e to the x sine 2x with respect to dx, let's find out what the integral of that is. So you would have u times v, so that will be minus 3 over 4 e to the x cosine of 2x, minus the integral of du over dx times v. So that's minus 3 over 4 e to the x cosine of 2x. Hang on a second. Look at this integral again. You'll think to yourself, okay, let's set u equal to e to the x. Let's set dv over dx equal to cosine of 2x. But you realize something very quickly. It's exactly what we've done here. We've pretty much got the same integral twice. So if we were to do this again and again and again, we would just end up doing this infinite number of times. It's just an infinite recursion, right? So if we were to do by parts, we would keep going on forever. So that's a dilemma we have. This is a paradox we have, right? So this question it feels impossible, doesn't it? How are you supposed to solve this? Well, you can do something very, very smart. Go ahead. You're on the right lines. Yeah, I'm very surprised. Yeah, you actually got it. Yeah, you use some form of substitution. So if you look at this, you've got minus 3/4 e to the x cosine of 2x. And then you could say minus minus. Let's bring 3/4 out. And then you've got 3/4 of e to the x cosine of 2x with respect to dx. So what were we doing here? Well, we were trying to figure out what? We were trying to figure out what is the integral of 3 over 2 e to the x sine 2x with respect to dx. So we were trying to work out what is this integral, right? So what can we do with this result? Okay, we can't integrate this. That's okay. Let's just keep it as it is, right? Let's not integrate it. Let's just keep the integral symbol there. So what can we do is I can just replace this with all of this. Do you understand? So let's do that. So let's just write this out. So you have the integral of 3e to the x cosine of 2x. So 3e to the x cosine of 2x is equal to 3 over 2 e to the x sine of 2x, right? minus 3/4 e to x cosine of 2x plus the integral of, so 3/4 integral of e to the x cosine of 2x, like so, respect to dx. Are you happy with this so far? Now I'm going to do something before I move on. We're going to do something very smart. So let's just bring this out. What I'm going to do is I'm going to say, let I'm choosing I because I stands for integral. Let I be equal to the integral of e to the x cosine of 2x with respect to dx. Does that make sense? So you would have 3I is equal to 3 over 2 e to the x sine 2x plus 3/4 of e to the x cosine of 2x minus 3/4 of I. Yeah, both of these integrals. What this does effectively is it prevents us from doing by parts again and again and again because we have the same integral twice that's appearing. So we can use that to our advantage. So that's what we're basically doing. So what do? Well, we just move this to the other side. So 3/4 plus 3. Can't do that in my head. 3 plus 3 over 4. So that's 15 over 4. So 15 over 4i is equal to 3 over 2 e to the x sine 2x plus 3/4 e to the x cosine 2x. So then I will just be equal to, and then you can just, multiply by the specific factors. So 3 over 2 times 4 all over 15. So that's 2 over 5. So 2/5 of e to the x sine 2x. And then you've got 3 over 4. So this should just be a fifth cosine of 2x. Do you have any questions on this so far? So what have we actually effectively found? We've just figured out that if you do the integral of e to the x cosine of 2x, it should be equal to 2/5 e to the x sine 2x plus a fifth of cosine of 2x plus c. Now we're not done there because the integral we want to do is 3 times that. So what we do, we just times it by 3, that's it. So therefore our answer is, 6/5 e to the x sine 2x plus 3/5. Yeah. The whole point of me showing you this problem is this is as hard as by parts will get. You will never get a question harder than this, because the obvious dilemma you fall into is, I do by parts once. Okay, I integrate. This is what I want to integrate. This is what I'm getting. Okay, let me do by parts again. Okay, I'm doing it again. Hang on a second. I'm just going to keep going on forever. But if you're very smart enough to realize, and I wasn't, okay, I can maybe do something now. I'm continuously integrating the same thing again and again and again. So could we utilize the fact that we're integrating, we're having the same integral as a result? Yeah, we can. Yeah. So that's really what you're doing here, and you're basically being smart about it. If you don't know how to do this, I don't think there's any other way of doing this question. Is there another way of doing it other than by parts? Probably. Is it in the textbook? Oh, it is. Okay. That's tough. No. I haven't seen it. Maybe it is. I haven't looked at the integration examples of the new textbook thoroughly. They don't have. Yeah, they don't really have an example, or they don't even have like an exercise. Even if you look on Solution Bank, I don't think you'll find a question like this in a Solution Bank, which is why I'm showing it to you now, because it wasn't an exam. Can you imagine something that's not in the exercises, something that's not even in the examples, right? It's not fair. Yeah, I know, but That's how they want to filter out students. I have very good news, though. I have very good news about this question. It's 5 marks, right? So believe it or not, if I remember correctly, when I was showing this question to another student of mine, 3 of the marks actually go towards these steps. So you'll get 3 out of 5 marks if you can just do by parts twice. That's it. They're very generous. If you can't finish the question and you just do by parts twice, you'll get 3 out of 5, and I think that's very nice. That's reasonable. And to say, oh, the last 2 marks will go towards all of this, that's very fair. This question is nearly impossible to do. If you're telling me there's only 2 marks to do all of this, oh yeah, it's obviously unfair, but at least you're not losing a lot for something that you don't know how to do, right? So I would say that's pretty fair. Okay. Let me just check that this is the actual answer to the integral. From alpha to tool. Integral of 3e to the x cosine of 2x. Do you have any questions about this example? Okay. Yeah, so this is correct. This is correct. I just wanted to check. Okay, great. Yeah, this is like, I'm just going to say this now. This is as hard as by parts will ever get. So just bear that in mind. I don't think there'll ever be a harder example than this on by parts. The only reason why I know how to do this question is because I was showing this in further maths. Can you imagine? So that's why I bring up this example to students. Oh, not only because it did actually come up in an A-level maths exam, but I was showing this in further maths. It's very interesting. Okay. What did you say? Yeah. That question is in an A-level maths paper, just heads up. When I was learning about this in 2016 or 17, when I was doing A-level exams, you know. Yeah, that's the old spec. All right. Separation of variables. Okay. Separation of variables. Okay. Separation of variables. Okay. The thing is with separation of variables is the questions I'll give you on it, they might not be too friendly. And what I mean by that is you would have to finish the modeling section of it as well, the section after it. Because a lot of the exam questions won't just be on solve this differential equation. It will be within context. So I do recommend, I know you might have done that in school, but before you do attempt these questions, make sure you have covered that section as well on modeling with it. And the exam questions will be a bit easy. That's just a heads up. Just to let you know. Let me see how many questions there are. I can guarantee you there'll be a lot of questions because it always comes up. Let's have a look. Oh, actually, not as much as I thought. 14 questions. 14. Why so little? Why so little, actually? I'm shocked, actually. Yeah, so just to show you before I do head off, Can you see my screen? Okay. So these are all the questions on separation of variables in past papers. This one's in context. Can you see? They modeled it. This is model. So they're saying, okay, here's a differential equation. Solve the differential equation. So here you would just use separation of variables. You would group the d theta and then this dt and k dt. So they put that in context. Let's have a look at the next one. Oh, would you look at that? That's also in context. Yeah. Oh, I'm very lucky here. This question's not in context. So there's no context behind this. Very rare for that to come up. Again, you're very lucky here. This one is also a question where it doesn't come up in context. This is very rare. You rarely see this these days. I guess this was a characteristic of the old spec, but they don't do that anymore. Again, modeling. Okay. Yep, you're lucky here as well. You can see here there's modeling involved. Yep, modeling here as well. Modeling here. Okay, no modeling here. Modeling here. Modeling here. No modeling. Modeling. Okay. It seems to be half and half. Quite interesting, actually. I wonder if it's because some of these questions are from the old spec. Do you know what you do for homework then? So because you haven't covered modeling yet in class, I guess. No? So what you do is just do the questions which aren't about modeling. So question 2, question 9. This one's a really difficult one. You'll be shocked. How many students have come to me because they didn't understand this question? Yeah, it's. I think in the past 4 or 5 years, I've had 6 or 7 A-level students. They've come to me stuck on this question, specifically part C. It's actually a lot more tricky. Even though it's show that, it's so hard to actually get this expression. But yeah, see if you can crack it. Yeah, have a go at this question. Anything that's highlighted, really, I guess. Yeah, have a go at this as well. This one's about partial fractions. Yeah, that one. Yeah, so there's just 1, 2, 3, 4, 5. 5 questions. 5 questions out of 14. You know, that one about modeling. So it's nearly 1/3. 1 in 3 questions. Yeah, I think it will be about modeling. When you do the past papers, when you do your past papers, right? When you've completed everything, you'll realize a lot of the questions in separation of variables will always be in context with modeling. Yeah. All right. That's good. That's good. I mean, with everything that we've covered, I think you're in a good spot with integration now. Even if you are getting some questions wrong, you should feel a bit more confident because now you know what to kind of expect in the exam, and you've actually had to practice a couple of exam questions. Just make sure you keep looking back and repeating questions that you've gotten wrong. That's very important. Yeah, I mean, I think you're in a good spot for the pure maths exams now, all things considered. I mean, if you're good at integration and differentiation, that's pretty much the 2 core components. You did chapter 10, you did Newton-Raphson and how do you call it? Iterative methods. That's really easy, right? It's really straightforward. Things like that, they're not that bad. Trig, yeah. Yeah, you just keep practicing. When you practice, if you're struggling with trig, Just practice as many proof questions with trig as possible. Not the solving equation one. I mean, you know you're good at those. Practice the proof once. Prove that this left-hand expression is equal to this right-hand expression. Practice a majority of those in chapter 7 and chapter 6, and you'll be okay. If you keep doing that and you keep going back on like the questions that you're getting wrong again and again, you'll be in a good spot. And just memorize those identities. If you do that, if you just practice the proof questions for trig and you memorize the identities, then you'll feel a lot better. I promise you that. Just do those two things. So practice the proof questions and then memorize the identities. And when I say memorize the identities, I just mean practice a crap ton of questions to the point where you just don't even need to look at the formula, but you still need to get to that point. You really do. I don't know, set a target by January or something to do that. Use Anki even if you want. That might actually be a decent idea. There might be flashcards already. Go ahead. I mean, if I'm honest with you, would you use flashcards for maths? I think I mentioned this like last week. No, but I mean, um, if you're not bothered to do or practice a lot of proof questions, then I mean, memorizing. If you're struggling to memorize the identities even after practicing so many questions, then yeah, might as well just use flashcards. But just do it to memorize the identities. You'll feel a lot better. I promise you that. But I mean, only do that as a last resort. If you're really struggling to memorize the identities, and do that. Okay. It should naturally come to you if you're doing a lot of questions. Yeah, but that's like 30 seconds to a minute of your exam time, like opening up the book. Of course, when you do your stats and mechanics exam, you can't help it. You need to use like statistical tables and stuff. So I mean, I don't really have a choice there. Um, have you started stat second year stuff? It's very it's a breeze. Yeah, it's a breeze. The only two things that you need to worry about are its normal distribution, and that's very fun. I think it's great. Um, I think it's really nice and intuitive compared to binomial. I think I mentioned that last year, not last year, sorry, a couple of months ago when we were doing binomial distribution. Binomial is great, but I think it's not intuitive. Um, it doesn't really have a lot of real life examples or real life um, cases to actually relate it to. Yeah, normal distribution curves, they're literally everywhere, which is why I think it's so nice to learn, because it's just it, it it makes so much sense in so many applications, and you'll see that when you do it. But with binomial, you can't do that. The only thing that you can probably use for binomial is like the flip of a coin, heads or tails, right? True or false, like only binary outcomes, right? One or zero. That's a problem. Um, that's that's all binomial is good for, which makes it very limited in its use case. The other problem with binomials is discrete as well, but normal distribution is continuous. That's also what makes it very nice and smooth, I guess, to learn about. You know, binomial doesn't have that luxury. Do you remember when we were doing hypothesis testing with binomial, and I told you to think of it as a curve, right? Um, that's why I think when you do hypothesis testing with binomial, that's why it's confusing. You can't really visualize binomial distribution with charts, nor do they tell you to. They don't tell you how to. The charts they give you, um, they're not nice to look at. The charts for normal distribution, however, because you've got a nice, clear way of seeing how it works, everything will just come to you. Everything will make sense if you're a visual learner. But binomial doesn't have that luxury. Um, Fun fact, before I do leave, did you know they used to teach normal distribution for AS, and then I think they used to teach binomial for A2. Yeah, yeah, I don't know why. I didn't need to learn about binomial in S1, which was so weird. I learned about normal distribution. Sorry, what did you say? That was an old spec, yeah. So I don't know why they did certain things the way they did. That's why I keep expressing my hatred for the new system, because I really don't like it. Um, but what can you do? What can you do? Oh well. Do you have any questions for this week? No? All right, cool. So just make sure you have a go at those questions for separation of variables. Um, and um, yeah, the highlighted questions. Then yeah, we'll go over them. All right. All right then. All right then. Take care. Bye.